Hello pre-calc students and welcome back. We are now at week 6 of distance learning, which seems absolutely crazy. And we are learning a new topic today. So we are now starting this idea of matrices. And matrices is just another way of representing our systems of equations. And so last week we started this idea. And I was given a matrix, and I said, okay, if I have 6, 3, 2, 4, 1, 5, 2, negative 6, 7, 8, 9, negative 4. If I had this matrix, because I have 3 rows and 4 columns, we would call this matrix a 3 by 4, right? We had this idea of matrix dimensions, we would say, and we went through those. And then if I said that I had matrix A is equal to 6, 3, 2, 4, 1, 5, 2, negative 6, 7, 8, 9, negative 4. If this was matrix A, and I wanted to find element A, 3, 2, I would go to row 3 and column 2, and I would find my element. So I go to row 3, column 2. So A32 would equal 5. So that's essentially what we talked about last week in our videos. And then furthermore, I said, okay, I gave this idea of what if we wanted to take a systems of equations and write it as a matrix. So say I have a system that's 6x minus 2y equals 14 and something basic like 3y equals 21. If I wanted to write this in augmented matrix form, I would write it like this. So I would have the 6 for the x, the negative 2 for the y, and the constant would be 14. And then since there's no x in the second equation, it would be a 0, 3, 21. Sometimes you see the dotted line, sometimes you don't. I'm going to try to write the dotted line, but sometimes I might forget, so hopefully I don't. So that's kind of what we talked about last week. We talked about matrix dimensions, identifying an element in a matrix, and then writing an augmented matrix form. Today, we're going to be focused on elementary row operations. So what that means is within a matrix, we can have these different operations that we perform to rearrange essentially how the matrix is, but it doesn't change the value. So our first row operation is that we can interchange 2 rows. And we would denote this as something like we would say interchange row 1 with row 2. So that's our first one. So the second operation is that we can multiply a row by a non-zero real number. So we can multiply a row by a fraction, by a decimal, by a negative number, by a positive number. We can multiply it by pi. We can multiply it by anything except for 0. And we would denote this and we would say, okay, let's do 3 times row 1. And then we can further say, and we're going to keep it in row 1. And then our last operation is we can add a row to another. or add a multiple of a row. And so how we would denote that is we would say, what if I wanted to do 1/2 of row 1 plus row 2, and we're going to keep it in row 2. Or I can just do row 2 plus row 3, and we're going to keep it in row 3. So the left-hand side are the operations that we're performing, and then the right-hand side is where we're keeping it. So it stays in row 1 here, row 2, and row 3. Okay, so those are our operations. It's best if we do practice with them. All right, so let's just make sure I'm set up here. So let's just take our first matrix that we had, that 3x4 matrix. So we had it, and I used blue, so we have 6, 3, 2, 4, 1, 5, 2, -6, 7, 8, 9, -4. All right, so let's say we want to interchange row 2 with row 3. So we're going to just swap those. So row 1 stays the same. 6, 4, 2, 8. And now we're going to just flip-flop row 2 and row 3. So this is now 2, 5, 7, -4, 3, 1, -6, 9. Okay. Now, let's say I want to do -2 times row 1, and we're going to do everything to A. So -2 times row 1, and we're going to keep it in row 1. Well, row 1 is what's changing, and we're multiplying everything by -2. Well, 6 times -2 is -12. 4 times -2 is -8. 2 times -2 is -4. And 8 times -2 is -16. All of the other rows are staying the same. So we keep 3, 1, -6, 9, 2, 5, 7, -4. So we multiplied. We can keep going. So let's say we want to add. Let's say we want to do row 1 plus row 2, and we're going to keep it in row 2. Well, row 1 is actually staying the same because all of this is going into row 2. So I can rewrite 6, 4, 2, 8. Row 3 is staying the same, so we're going to do 2, 5, 7, -4. Now all we have to do is add row 1 and row 2 together, and we'll put it in this middle. So 6 plus 3, 9. 4 plus 1, 5. 2 and -6, -4. 8 and 9, 17. Okay. Let's say now what we want to do is we want to do 2 times row 2, add it to row 3, and keep it in row 3. Well, I always like to stay with what's staying the same. So we know that we're going to keep row 1 the same, so 6, 4, 2, 8. We are adding row 2 and we're doing something with it, but this whole thing is going into row 3, so row 2 actually stays the same as 3, 1, -6, and 9. And now we have to do a little math to figure out row 2 plus row 3. All right, so I have 3. Remember, I'm starting at the original matrix. So I have 3. 3 times 2 is 6. And now I'm doing 6 plus 2. So this is 8. So I took the 3, I times it by 2, and then I added the 2 in row 3, and I got 8. Now I have to take the 1. 1 times 2, add the 5. 2 plus 5 is 7. Now we take the negative 6. Negative 6 times 2 plus 7. Negative 6 times 2 is negative 12. Negative 12 plus 7 is negative 5. And now we have to do the negative 4. Negative 4 times 2. Nope. We have to do the 9. 9 times 2 plus negative 4. 9 times 2 is 18. 18 plus negative 4 is 14. So that is the new matrix. Let me scroll that up. So elementary row operations. We're just performing operations to each row to create a different version of the matrix. Again, we can do 3 things. We can interchange 2 rows. We can multiply a row by a constant or a non-zero real number. Remember, it can be a decimal or a fraction. We can also add rows to another and add multiple rows to another. So let's do another example. Okay. All right. Let's start with our matrix A. And we're going to have a 2 by 3. So we're going to have 2 rows and 3 columns. 2, 5, 3. 3, 4, 6. Now, Khan Academy doesn't put the little dashes, so I'm not going to put the dashes in this one. Okay, so the first operation that I want to do is I want to interchange row 1 with row 2. So the new matrix is going to look like, since they're both changing, I'm going to keep the color in my hand. This becomes a 3, a 4, a 6, and this becomes a 2, a 5, and a 3. We just switched the rows. Okay, so now let's say we take row 1 and we multiply it by 3, and we're going to keep it in row 3. Well, row 2 isn't changing, so we keep 3, 4, 6. Row 1, we're multiplying everything times 3. So 2 times 3 is 6. 5 times 3 is 15. And 3 times 3 is 9. Okay. Now we can also add the rows together. So let's do row 1 plus row 2, and let's keep it in row 2. So for this example, we have to think which row stays the same. Well, since it's ending up in row 2, we know that row 1 stays the same. So this is a 2, a 5, a 3. And then we add the 2 rows together for row 2. So 2 plus 3 is 5. 5 plus 4 is 9. And 3 plus 6 is also 9. So we added the rows together. Okay, and we can do, let's do one more. Okay, so we're gonna start, now we're gonna do a 3 by 3 matrix. So we have 4, 8, 3, 2, 4, 5, 7, 1, 2. All right, so our first operation that we're going to perform on this matrix is let's interchange rows 2 and row 3. All right, so what rows stay the same? Row 1 stays the same because it's not doing anything. So that's going to stay 4, 8, 3. And then we're going to just change row 2 and row 3. So row 2 is now 7, 1, 2, and row 3 is now 2, 4, 5. Wonderful. And let's say we have 7, 6, 1, 2, 4, 3, 9, 1, 12. So again, this is a 3 by 3 matrix. Let's change it up a little bit. Let's do something a little bit more challenging. Let's do negative R1, add that to R3, and let's keep it in R3. All right, so first thing I'm going to do is I'm going to write down what is staying the same. Well, R2 is clearly staying the same because it's not even in our operation. So we're going to keep row 2 as 6, 4, 1. Now, even though we're using row 1, it's actually staying the same because we're moving everything to row 3. So 7 to 9 stays the same. And then now we just have to do negative row 1 plus row 3, and that's all going to go here. All right, well, negative 7 plus 1, negative 6. Negative 2 plus 3 is positive 1. And negative 9 plus 12 is positive 3. And then one final example. Start with 6, 6, 1, 2, 3, 0, 4, 5, 9. Let's do notice how none of these are subtraction. If we want to do subtraction, we would do a negative. So let's say we do negative 2 times row 2, add it to row 3, and let's keep it in row 2 this time. All right, so row 1 stays the same, 6, 6, 1. Row 3 stays the same because we're going to row 2, 4, 5, 9. So now we just have to figure out what goes in row 3. So we have to do negative 2 times row 2 and add it to row 3. So we do 2 times negative 2, add it to 4. 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. Now we do 3 times negative 2, add it to 5. 3 times negative 2 is negative 6. Negative 6 plus 5 is negative 1. And then we do 0 times negative 2 plus 9. 0 times negative 2 is 0. 0 plus 9 is 9. So again, our 3 operations. So eventually the goal is to be using our matrix operations to solve systems of equations. But right now I just want you guys to get the practice of going through and performing the elementary row operations. And then next week we'll use these row operations to solve systems of equations. All right, my friends, so after this video, you're gonna practice on Khan Academy, and then there's a Google form. Good luck, and ask questions when you need them.